Hey, guys, we are at the top of the hour. Who wants to kick it off? Should I? Does this need to be official or something?
It's all you, UC. Oh, hey, Nick's here.
You're the official webinar kicker offer, UC.
I'm glad I have a position in this company. Finally, you know, my career has a meaning. All right. Thanks everybody for joining today to this ECAHA webinar. We're going to talk about stadium Wi-Fi, and probably going to be centered around, you know, designing stadium Wi-Fi and the special characteristics and stuff like that. And we have awesome guests and everything on board today. So thank you so much for joining. I know you know, it's close to Halloween time already, so we won't take too much of your time. Oh, look at that. I went way overboard there. Looks like my PowerPoint isn't working as per usual. Anyway, so I was going to show you a slide about what you're going to learn today. So a couple of things just to spill the beans before we actually go to the beef. So if you only stay on for 2 minutes, this is what you will learn today. Stadiums are different. You need to care about total system throughput and you know, high SNR and getting some channel reuse there would be nice. What do you guys think? Actually, you know what? I'll just show the agenda and then we'll switch to Scott, and Scott can maybe drive this whole thing better than I can. So about the agenda, we're going to talk about stadiums. We're going to talk about design deployment considerations, and towards the end, we'll kind of, you know, start curveballing wild ideas like 802.11ax. Maybe, I don't know, should we talk about like the added value experience on the stadium? I don't know how much you guys have done, you know, this BLE / some kind of location tracking / ultra wideband for tracking players. I don't know, but we can talk about that fun stuff towards the end as well. But Scott, you want to drive this, or should I drive your keynote presentation? What do you think?
I can go ahead and drive it easy. It's no big deal. Let me get.
All right, awesome. Thank you. Because you have all the, you know, introductions and everything there as well.
Yep, I got you. All right. I'm going.
You is control. Or is you?
I think UC has to not be sharing to do that.
All right. Let me see if I can do that.
I'll take this opportunity to remind everybody, especially those still joining here or have joined recently, the Q&A panel is open there. You can submit your questions throughout the webinar, and you can even see the questions that have been submitted and upvote them if it's a question you'd like to see answered.
All right.
And this is going to be a panel webinar. So whenever you have something, you know, you want to throw a curveball at us or anything, just, yeah, use the chat board, use the Q&A, and maybe we'll take them live. Maybe we'll take them towards the end. You know, maybe they will be carved into the Hall of Fame. We don't know. All right, Scott, we can see your screen, man.
All right, good.
Take it away.
All right, well, good afternoon, good morning, good evening, wherever you might be in whichever time zone you're in across the world. Welcome to our Stadium Survival webinar. Excuse me, a little tongue-tied already on Halloween, and the parties haven't even started yet. Let's see, moving on. All right, I think we'll just let everybody introduce themselves. I think you pretty much already know the man that's already been talking. I'm the top right, Mr. Mummy Wi-Fi. Scott Lester, CWE number 253. I work for Layer 3 Communications in, or just outside of Atlanta, Georgia, rather, and been doing stadium, LPV, VHD, whatever you want to call it, wireless, for a number of years now, and have worked in several different professional stadiums as well as collegiate stadiums across the world. So that's me. Chris?
It's got a couple of curveballs at you right there. Layer 3 is a systems integrator in southeastern US, or?
Yeah, that's correct. You see, Yeah, that's correct. Layer 3, we're headquartered in Norcross, Georgia. We've got offices all across the Southeast, from Houston, Texas, Austin, up into Nashville, all across various states, from Georgia, Savannah, Birmingham, Alabama, just to name a few of our locations. So we primarily handle integration duties for a number of different vendors, platforms across the southeastern U.S., and can even extend a little bit outside of that if need be.
Excellent. Thank you. And if you had to name one stadium you have been involved in.
One stadium. Well, I could tell you.
And I know it's a tough one, right?
I could tell you, but I might have to kill you. So I don't know if we want to talk about the Washington Nationals. Oh, dang it. I did not mean to say that out loud.
I'm glad you didn't, man. All right.
All right, and I'm Chris Reed. I'm the lead network engineer at BEI Networks. We're a services and consulting group out of New Hampshire, but we have people across the U.S. and cover U.S. and then a little bit outside of, depending on how much they're willing to pay us to travel. So I've been working in LPV and stadiums since about 2012. Done numerous professional football, basketball, and starting to get down into some of the AAA and college at this point now.
Very cool. Thanks for joining both Scott and Chris. It's an honor to have you guys on board.
Yeah, thanks for having me.
Yeah, I appreciate the invitation.
And I'll be the Jer Bones here, aka Jerry. I'm a product manager here at Ekahau. Welcome everybody to this special Halloween edition here of our webinar series. But yeah, this one definitely appeals to me. I've recently gotten to participate in some survey and Wi-Fi projects that have taken place at some stadiums. And that's been a new kind of experience to me. I've got previously a lot of experience working in a lot of other verticals, but stadiums is one that I haven't had a lot of experience in up until recently. So it's definitely been eye-opening. So certainly interested to hear what Chris and Scott have to share on that topic, given that they have a lot more insight than I do.
I don't know about insight, Jerry. I just read the Dummies Wi-Fi book at Wi-Fi Trick a week ago, so I'm not really sure I'm qualified for this.
Well, you're off to a good start at least then.
Yeah, I did stay at a Holiday Inn Express last night.
Perfect.
Yeah, one of the stadium guys, Chuck Lukashevsky, also seems to be reading the Wi-Fi for Dummies book at the show. I don't know if you saw it on Twitter. So just for audience's sake, go on Twitter, follow us. There's a lot of fun stuff there, and some of it relates to Wi-Fi as well. Anyway.
Cool. So we just kind of touch base on what we're doing, who we are. So everyone kind of knows us now. You can go find us on Twitter. Feel free to drop Nicolas Cage images to UC all day long. He loves those. He has quite the collection moving on things. But anyway, we'll just kind of get to the topic at hand today. So we'll just talk a little bit about stadium Wi-Fi. We kind of wanted to address it in a few different aspects. So we'll start off talking kind of about the design of stadium Wi-Fi, kind of tips and tricks we've learned over the years, things that we try to look for to build our designs out more fully, some best practices, if you will, around that. We'll kind of touch on then a little bit of the design from an RF perspective, not just the physical that we'll start off with. Go through a little bit of what I might call a troubleshooting, if you will, for stadium wireless. And then we'll kind of end on some not stadium things necessarily that have to do with wireless anyway, about things that you need to look for outside of just your wireless deployment within a large venue, a stadium, an airport, a large convention hall, wherever it may be. So we'll just kind of flip through a few little slides here. Guys, feel free, audience as well, if you have any questions along the way, just let us know. We'll be glad to kind of touch base on those if it's something that we're not going to talk about later in the prezo. So don't feel offended if we tell you, hold on a second, let us get to the punchline. So you can just kind of see a little bit. I just put a few different stadium architectures up just to give you an idea of some of the types of environments that we work in. I mean, we're all familiar with what an athletic stadium looks like from, whether it be a soccer field or football for use people over in the European regions. American football stadiums, basketball, just a number of different stadiums, and they all present, as you can tell, a different and unique architecture that we as wireless engineers have to design around, but depending on a number of different circumstances, and as well as trying to take into account what the use case of that environment may be and what I would contend that arenas are not stadiums. It depends on how the verbiage there. That's just a verbiage thing, in my opinion. I think that they both can be considered a stadium of some type. I don't think that we'll, for the sake of our discussion here, have any kind of finite definition of what a stadium versus an arena is. We'll just contend that
they have similar approaches to the designs.
Yeah, but is there a definition like arena versus stadium, if like number of seats or the structural, or are they pretty much synonyms? Or
well, these days I think with the architecture of stadiums overall, with more enclosed domed stadiums, that have retractable roofs and all of that nature, I think that's kind of where I approach it. As I don't really feel like there's a definitive line now between what an arena versus what a stadium is.
Okay. I'm Googling it, and an arena is typically enclosed and a stadium sometimes has an open roof. Football is usually played in a stadium, while basketball and other sports are typically held games in arenas. Not that this was the purpose of the webinar, but just for you nitpickers, not naming any names, but who was it? Ethan. Anyway.
So
we're clear.
All right. So we'll move on to kind of anatomy of a venue, if you will. If many of you have ever looked at how stadiums are built from the ground up from an architectural perspective, right? Typically, these things are built from the inside out, if you will. We start at the bottom, the foundation level, if you will, of the event level, and we kind of build our way up out of the ground as you would see construction proceeding until we finish all the way out to the upper bowl and then actually close in the stadium or arena itself. So as we look at the different layers, if you will, as we've kind of have them drawn out here in the different colors, when you're a wireless engineer approaching a project where you're providing a wireless network design for a facility such as this, I think it's something that drives a lot of thought behind what the purpose of each level in that facility would be. Chris, do you want to kind of talk about, how you would approach a multi-tiered design like this?
Yeah, absolutely. So the couple of things to consider within stadiums and arenas is that it's not just the bowl that you're trying to service. That there are the concourse areas, the suite areas. There's indoor carpeted enterprise spaces for the business. There's education spaces if the team has practice and training facilities there as well. So there's a lot that you have to look at and sort of treat it a little bit separately. But for any of the designs, my methodology is to start in the bowl. That you design the bowl and then you fit other things around your bowl design, your bowl placement, and your bowl channel plan. If you were to try to work your way outside in instead of inside out, your concourse is a lot easier to shift around to support your bowl. If you've set your concourse and then try to shift the bowl around, it's cascading changes across the entire bowl that you have to make. So if you start in the bowl, work your way out, then you shift the concourse and suite areas to fit within the channel plan and within the design that you've put forward in the bowl.
Yeah, I think that's a good point. It's something we typically do is with designing the bowl first, right? Is we want to make sure that when we provide coverages outside of that bowl area, that we're able to make sure that those areas such as concourse areas, suite levels, things of that nature, that we're not impeding upon the signal that we're trying to spread in our bowl areas themselves, right? Because your bowl, outside of maybe, the beginning entry areas or the ending exit areas of a stadium, right? Your bowl is going to be typically your largest concentration of users throughout the event. Now, obviously, intermissions, things of that nature, change that up a bit. You'll see people moving throughout the stadium and all like that. But I would say by far the bowl, being that it's where our spectators or our fans or patrons are sitting, are the places that they need to be focused upon the most, if you will. So, when we're looking at providing bowl coverages, for instance, there's three, most, I would say, widely used methods that come to mind. First off, and, in every case, no matter what the stadium is, it's just like a wireless design for a building. Even if you had an identical building, the wireless design itself for those two identical buildings are going to be a little bit unique and a little bit different. And each of these methods kind of has pros and cons, if you will, of how they're used within a stadium, when you can use them in a stadium, and what purpose they serve from a coverage perspective, if you will. So as we kind of look at these, I would say that, in my estimation, and Chris, feel free to chime in, and everyone, I think that the three most widely methods that I see typically used in a stadium deployment from a wireless coverage perspective are handrail coverages. You've got handrails down each aisle. You're going to put a wireless antenna on each of those to kind of provide coverage horizontally, if you will, into the seating areas. You have an overhead design, right, where you're attaching to something like a catwalk or some physical infrastructure piece of the stadium or arena itself to kind of provide coverage with. And then you've got an underseat model as well that everyone's, heard of, seen in a lot of cases these days. And like I said, there's kind of different use cases for each of those, I think. So.
And I'm sure there's is it most stadiums have a combination of many of these? Am I right? Or is it always like you only do underseat, or you only do, I'm guessing at least often it's like a combination of handrail and overhead. And then, more and more, I guess I'm seeing more and more, at least to my experience, people gravitating towards underseat wherever possible. Is that a fair estimation?
So there are some problems with mixing design methodologies, particularly within the bowl spaces, that oftentimes you'll have, even with underseat, is that you'll have an overhead directional deployment out in concourse spaces, or maybe shooting back away from the bowl in some of the maybe some of the outdoor premium areas up high. But when you mix the deployment models, you may have an overhead shooting down across multiple railing sections, is that you're having a tougher time containing your cell, if you will, and you're shooting it far across multiple coverage areas of other antennas. So your roaming may have some problems. You may have clients connecting to access points and radios that you may not want them to connect to. So oftentimes we try to stick with a single deployment methodology whenever possible.
Yeah, I mean, for the most part, I would agree with that. You try to stick to one model. However, I think there are some cases, though, where, whether it be, someone during the construction phase of a new facility dropped the ball, and maybe a key piece of conduit, that needed to route from one IDF into a particular stadium section was missed, or maybe was filled with concrete. Not that ever happens in construction. But I think, so I think for the most part, we do try to stick to one, but sometimes there is a unique use case, corner case, if you will, where you do have to maybe mix methods a little bit just to make sure that you get some coverage in that area. I know, Jake Snyder, I believe, is on with us. He's famous for saying, some coverage is better than none, especially when it comes to interference. So I would rather have co-channel interference than none at all as far as coverage goes.
Yeah, I believe his trademark is better co-channel than no channel.
Yeah, there you go. I was sorry about that, Jake. I got a little bumbled on the wording there of it, but I think that just goes to show that there are times where maybe mixing in a small area of an arena is kind of unavoidable, if you will, to be able to provide coverage for the spectators.
So I'll add in
after
one
all,
thing.
you want. Yeah, sorry. Go ahead, Jerry.
I was just going to say, I'll add in that I have seen the approach of initial design was done using overhead, and then as requirements changed, they used handrail, adding additional access points using the handrail method to kind of revise the design, if you will. I don't know if you've seen that, or if you have any experience with that of any issues maybe that could potentially pose as well.
Why don't I think we have some visualizations for each of the overhead, the handrail, and the underseat. Why don't we talk about those, each of those models, the pros and cons for them, and then we can sort of circle back to that and talk about why you'd use it in some areas and not others.
Yeah, man.
Yeah, so we'll kind of start off with just overhead coverage, right? I think we would all kind of agree that overhead coverage by far is the simplest deployment strategy that you can put out there, both from a cost to deploy, from a labor part, as well as from the number of access points, right, that you would need to use in a facility. Obviously, there's a lot of factors that go into that, right? Like what beam width of antenna are we going to use? Where are we able to mount an array like you see in the image here with the multiple antennas on it for the different seating sections? And there's a lot of things like that that come into play. But by far, I would consider overhead the easiest to deploy. Is that kind of the sentiment from everyone?
Yeah, I think easiest from a construction effort,
Yeah.
but not necessarily from a design and tuning perspective.
Sure, absolutely. And you kind of brought up a good point, right? You'll see the last bullet there is talking about difficult to control cell size. I've seen a lot of cases where it definitely is very hard to maintain those crisp spell edges across the environment. However, I think one of the benefits that I particularly like a lot about overhead is it gives you by far the highest average SNR for all of the clients in the cell, right? Because there's always going to be that clear line of sight between the access point and the client device.
So
yeah.
my question on the overhead thing. It gives you good SNR, but doesn't that give you, a pretty decent signal level across the entire freaking stadium? It's just impossible to control RF so well. You put one of those APs with an antenna combinations you see there, and that can be heard almost everywhere in the stadium. Is that correct?
Yeah, but I think you see that's kind of, regardless of the coverage model, whether it be overhead or underseat, in an enclosed arena or a stadium, most of the time, because of the fact that wireless is just so dang resilient and the propagation is so great, even at lowest power levels that you're typically going to see deployed in a stadium, you're typically always going to see beacons from most every AP that you're going to deploy.
Really? For a full stadium and underseat? Really?
Yeah.
Stadium underseat. I'm just arguing. I don't know. But just curious.
Tell you what,
you put 22,000 people, 50,000 people
Sure.
on their seats, and you have underseat, and you're saying, the furthest AP can be heard in the absolute furthest other corner.
It's not necessarily the AP, but it is the client, because you can focus the signal. You can focus the signal all you want with the access point, but the client's response is always going to be omnidirectional. And when we're only dealing with free space path loss, which we are in large venues, across the venue, one client will be able to see the other client's response. So you have to sort of plan for that.
And you see, I've even got a slide for that later where we'll show you where Jerry actually gave us some data from a live professional stadium that he took showing that very thing.
Awesome. I look forward to that.
So talking about difficult to control the cell size with directional antennas, you have to remember that when you pick a 35-degree antenna, it's 35 degrees when, if you're looking at the azimuth drawing, that it drops 3 dB in that. It still has more of a side lobe. So you can't just do math to figure out it's a 35 degree, it's going to end here. You have to do the testing when you're doing the deployment, you're doing the tuning, and you're doing the design. There's a side lobe and there's a back lobe that you have to account for.
Yeah, there are. And you'll see a lot of antenna manufacturers, specifically, I know Ventive spent some time around this. I know Aruba has some specific stadium antennas that they typically recommend for use that have been carefully engineered to actually engineer those side lobes out. So that the fall off is actually absolutely dramatic, if you will, when you look at how the propagation is out of that antenna into a certain situation. I think from a backload perspective, right, that's one of those that you're always going to have a little bit of backload regardless of how much engineering goes into the antenna itself. But there are specialty antennas that we'll use. And you bring up an interesting point as well, talking about the degree beam width and all of the antenna. So just some quick math, right? Let's pretend as though our coverage out of antenna is a concentric circle. And we all know that by far it is not a concentric circle, but just to make the math easy and to give you some idea of how important it is, not only where you can mount the antenna, but height of antenna away from the section and stuff. So I've done a little bit of math for you, a little bit of trigonometry. So if you utilized a 30-degree beam width antenna and you mounted that antenna at 50 foot from the user device, you're going to look at about roughly a 58-foot diameter in your cell size, right? Just rough math, right? If we extend that out, so we say 50, well, 50 is probably a little close for a lot of different arenas and places that you might be deploying. So let's say we go to 100 feet. Just a 50-foot increase in the distance away from your intended coverage area increases your diameter from 58 feet wide to 116 feet wide, right? So if we think about how many people we can cover with a single 116 foot diameter pattern, right? We're talking about probably vastly more devices than you would ever want connected to a single access point. So kind of moving on, if we will, just for sake of time, right? We talk about our second coverage model, right? Where we're talking about handrail coverage, right? Handrails, something that I'm starting to see a little bit more of. It's probably actually my least favorite. Chris, you have some thoughts around that as well?
Yeah, absolutely. Handrail can work in certain scenarios, but you are 100% at the mercy of wherever the architect put the handrails. And as we know from where architects place APs, we don't necessarily want that. So you've got limited mounting locations that you can do. If you're more than, if your sections are more than, I don't know, 20 seats wide, maybe, that you've got these wide gaps in the middle of it that just aren't going to be serviced well by a handrail only deployment. So it's definitely my least favorite, but on the overhead as well, it's sort of in the same scenario. You're at the mercy of where you can mount them, mount the antennas. So for handrail, you've got this strip up the middle of the section that you can mount them. For overheads, unless you're making something dropping down from the ceiling, you're at the mercy of where the actual support steel is for those directionals.
Yeah, absolutely. You touched on kind of the key point that I kind of look at when I'm particularly dealing with handrail antennas, right? Once you get about, if you're using handrail antennas in your aisles, once you get about 10 bodies in, right, you start seeing that fall off pretty precipitous as far as what your usable signal is then for that 11th, 12th, or 13th person, right? So, I've seen these deployed in some large professional football stadiums here in the United States. And, sufficient to say that it was probably one of the methods they thought would work well, but what we've actually seen in reality is that the overall system throughput, right, and the average SNR for your users actually drops off pretty dramatically once you get to a certain point of about 10 people in. Unfortunately, right, water degrades wireless signal propagation, and that's what humans are mostly made of. So it's just one of those things that regardless of what we try to do from a power, an RxSOP standpoint, whatever trick you want to use in the book, it's kind of hard to overcome those big water bags that are sitting in the seats. And then not to mention that, right, but there's also a increased cost to deploy a handrail antenna, right? You're talking about potentially having to use a greater number of access points, but then you're also looking at things like, well, does the stadium already have handrails in place, right? Because if a stadium doesn't, then, you're looking at, having to deal with such things as ADA restrictions. Well, if I put a rail in now, does my stadium have to fall under complete ADA guidelines? So am I going to spend, $10, on this AP, for instance, but I'm going to have to spend $100 million to make my entire stadium ADA compliant, right? So those are things that you also have to look for as well. Not just the.
So what is ADA?
So ADA is the
idiots.
Yeah, so for those outside of the United States, that's the American Disabilities Act. There's some guidelines that you have to follow, based on certain criteria to allow accessibility into a venue like this. A lot of places you find are grandfathered in, if you will, so that they don't necessarily have to abide by them. But those are also venues that if a single change of any type is made in some cases, depending on what that change may be, it could bring the whole stadium then under the realm of ADA, and they would have to abide by those then moving forward.
All right. Thanks, man. And sorry for my ignorance here.
No, that's quite all right. I have to remember that we have a global audience here. And then kind of as we just move on to our kind of third and final design, we'll talk about underseat coverage, right? I think, and Chris, your thoughts are welcome on this as well, but I think the underseat design is probably the most difficult of all designs to actually deploy.
Yeah, so from an actual deployment perspective, that it's absolutely the most difficult. There's the most APs, which means more cables. You've got to do a lot as far as enclosures and aesthetics to make sure that they fit with the venue aesthetics, because they're right in the face of the clients. And then there's things like having to core through concrete to take care of, or if it's a slab on grade, or the seating is all just on grade that you can't core through. There's nothing underneath it. So you've got to figure out some sort of tracking solution, which is not, there's nothing off the shelf for that you can use in a permanent install. So it's all oftentimes custom, unless there's an off the shelf one that you know of. I haven't been able to find one. So it's all custom. But the benefit to underseat is that if you can maintain MPE, the maximum permissible exposure, so the distance between the radiating element and a stationary component of a person, that you've got basically unlimited options on where you can go for the underseat. So
and you talk about maximum permitted exposure, right? As far as the U.S. is concerned, I think that guideline is generally just a small amount of we're measuring in centimeters, right? It's not that we're talking about it's got to be a foot away or 2 feet away from the body.
So it's I believe there's two different levels for it, and one of them, if the manufacturer with the antenna model goes through some different testing, they can shrink that distance. But for the most part, I believe it's 20 centimeters off the top of my head. So oftentimes, unless it's if you've got chair backs, for the most part you can make that happen.
Definitely. Sorry, there was a question on that topic, so I just wanted to make sure specifically around it, if that's something that the FCC regulates, or where is that kind of governed by?
Yeah, that's an FCC regulation.
Okay.
Yeah, so obviously, depending on if you're dealing with FCC, ETSI, whoever your governing body may be, that may be a little bit different depending on your region of the world.
Good point. Yeah.
But I think the good thing about underseat, though, right, is, by far I would consider it the most efficient use of RF, right? Because if we look at our other previously mentioned coverage models, if you will, right, when we're looking at overhead, right, we're essentially beaming down into, the abyss, right, trying to cover, the seating that as we need to, right, depending on cell size, depending on number that we want in that particular cell, things of that nature, right? But we're essentially shooting at each other, and it's very difficult, especially in some venues, right, to control that cell size so that you get those crisp edges, and you avoid the overlap then that kind of can cause issues with device roaming and saying, okay, well, which AP do I want to connect to, right? Do I want to connect to this one? Do I want to connect to this one, right? I think, in most cases, where I'm concerned, if we're looking at an office building, say, for instance, a generic Wi-Fi deployment, I'm not as particularly concerned with which AP necessarily a device is connected to, right? As long as the experience is good. And to an extent, that's the same within a stadium or an LPV venue. But there are kind of design guidelines that we need to follow as far as, how many devices do we want per access point radio, right? So we can ensure the greatest amount of what we would call total system throughput, to borrow a term from Chuck Lukashevsky's VRD for stadium guides, right? There's something that we want to, design around to make sure that we have enough space on our access point as far as association IDs, and that we also allow, transient users to be able to move through the environment while our stationary users are still there using the network to a good extent. But from an underseat perspective, right, we have the benefit of our RF, right, is essentially spewing out into space, right? So rather than having destructive interference, right, from an overhead or a Henro deployment where we're shooting signals at each other, in some cases, with our underseat model, right, for the most part, we're going to direct that signal out into space. So we have, a much better chance of being able to potentially use a channel multiple times depending on the size of the venue. And right, there's a lot of things that kind of go into that. Reuse, if you will.
So there's a
couple of things about underseat. that I noticed. So first of all, we were with Rob a couple of weeks ago. We had the privilege of getting a tour of the brand new LAFC Los Angeles Football Club stadium, which was Underseat. It was ruckus, and actually on the chat board I put in a link. We shot the YouTube video there with a couple of the VPs of the stadium, and they mentioned that the challenge was it was a brand new ruckus system, and they had to design an enclosure for the Underseat, and cleaning the stadium and the associated pressure of the water was initially a challenge where they had to reinforce the casing. So the casing, I'm assuming, is pretty important in all deployment types, but especially in Underseat, and that's not the first stadium I've heard complaints about that. So if you're interested in those videos, check out the link on the chat board. What do you guys think? Like the enclosures, Underseat, have you heard of similar problems?
Yeah, so I've actually had that happen in an arena stadium that I've actually worked in, UC. So it is very important that the enclosures themselves get installed properly. I've heard other stories from other venues, such as the handrail enclosures, right, that were actually installed improperly, where there was, a gasket improperly installed, or maybe pinched or missing completely from the enclosure, right, which then, essentially after a good, one good rain, filled the enclosure up, and the access point at that point was, a good paperweight.
The importance of the enclosure and either waterproofing or draining of it will vary depending on whether you're using an indoor product inside of it or whether you're using an outdoor product inside of it. Sometimes you can get away with more just an aesthetics enclosure if you're using an outdoor product inside, as long as you can make sure that it's draining properly and is not getting completely submerged.
Any issues you guys are aware of?
Yes. Sorry, go ahead, Jerry.
Oh, sorry. I was just going to ask one of the questions. There's a lot of questions actually coming in around this, so this seems to be a pretty popular topic or relevant topic to our audience here. So one of the questions was around with the Underseat. Any examples or any with the deployments that you've done around vandalism or theft or anything like that with them being under the seat?
I personally haven't seen any, what I would consider intentional vandalism. Obviously, right, anytime you're putting a piece of equipment of any kind where, spectators and all are going to be in close proximity or direct contact with, it's something to think about. But at least, in the venues that I've worked in over the years, that's not been an issue that I've run into.
Yeah, the only issues really we've run into is once the deployment is final, we haven't had any problems with either with missing enclosures or covers or screws or that kind of thing. That during construction, depending on how good the crew is about cleaning up after themselves and making sure everything is secure before events, you may find some missing things after the event.
Yeah, I mean, it's definitely possible. I would say by far, though, the largest kind of factor in that would be, unintentional damage, if you will, from someone that was, walking by and maybe, poured something into it or accidentally kicked it. I wouldn't say that it's necessarily always a target for your spectators.
We did have, I think there's someone on the webinar that was present for this event that during a construction effort that the enclosures were secured but didn't have anything in yet in one of these sections, and then after the event there was the hole that you saw where the mounting screw went into the concrete, but the enclosure was not there anymore after the event. So someone picked up an enclosure and walked out after the event with the entire thing.
Wow. That was their World Series trophy, right? For winning the.
No branding on it or anything, so it's definitely not not something you can say was from this particular venue.
That kind of answer your question, Jerry?
Yeah, no, I think that answered that one well. We've got a couple other questions around the Underseat. I don't know if we had anything else we wanted to talk about there, but we could cover a couple more questions.
Okay.
Well, yeah, go, Jerry. Hey, I have one question too. does the seat actually warm up if you do an U-class speed test against the AP on a cold day? Can you like pick your seat so that you get the warmest seat?
Is that going to be an UCLA feature?
It will.
I thought that was only if you had a sidekick under each seat, you see.
No, but I mean, seriously, if you think about it, the AP is a pretty powerful computer with a couple of pretty beefy radios. And if you really stress test the AP, there's a lot of them. Anyway, Jerry, you probably had some actually reasonable questions in front of you.
They're just from the audience. You can rattle on about stuff all you want, you see. All right.
Thanks,
so
man.
the next.
I mean, so I will address UC. I will say that the heat is definitely something that you need to be concerned about, right? Anytime you're using an enclosure with a piece of electronic equipment inside, right, there is going to be heat generated, right? We've all seen access points. We know the size of the heat sinks on the backs of some of these things, and how much heat they can actually generate. If you pulled one that's in service off of a ceiling pretty quickly. So I think it definitely is something to be concerned with. Typically, these things are the enclosures themselves are designed with some sort of venting so that we're not having to necessarily worry about overheating of the access point. And that venting is designed in such a way that typically will allow, or I should say, prevent the entrance of water or other, fluids into the box itself.
Yep. Yeah, a lot of
very good. And while Jerry asks questions, Scott, I just public tweeted you a picture you need to share.
We'll pick that up at the end.
All right. So Anders had a question around the radius. What is the typical radius of an AP that's in an underseat design?
So that's largely going to
level.
Yeah. So if we're talking about the signal, what I would call the usable signal level right out of an access point, that's going to fluctuate depending upon each stadium, right? What is your intended coverage area? What is the power level of the access point set to? What is the gain of the antenna? Because we're concerned, right, with what our coverage is, both from a power perspective as well as from a physical RF perspective of how large of a net, if you will, are we casting. And then it depends upon a lot of other things too, like, what are our seat widths? What are our row widths? Things of that nature. Is it an empty stadium or is it a full stadium? Even can affect that greatly, right? Because obviously as we have an access point broadcasting a certain signal, then we add in, say, 70,000 spectators that are all sitting on top of our access point. Suddenly that coverage radius or, that RF domain shrinks greatly, right? Depending upon the attenuation of people in those seating sections.
Yeah, and when you're looking at the stadium designs initially, and where you're going to be setting the power, is this a national championship team that is selling out constantly, or is it someone with a really large venue that is quarter capacity all the time? That your power levels are going to change depending on the answer to that question, depending on the area.
Right on. One other question on the AP boxes themselves. Have you guys worked with different boxes? Have you found ones that work better than others for, one for obviously, keeping things watertight, but also for, cooling or other factors there that you like to work with?
For me personally, I think that depends upon what manufacturer I'm deploying, right? Because each access point from a manufacturer is going to put off a different amount of heat, so that may warrant a different box selection. Oberon makes some great enclosures. Ventive even has some enclosures as well. I think Exceltex may have some as well now, specifically designed kind of on that angled approach to fill in the gap right between the concrete seating level itself, right? So that, it holds the antenna, are you holding the antenna, parallel with your seat, or are you holding it at an angle and offset, things of that nature? So those are kind of just some of the vendors out there that I've used products from. As far as any in particular, I think I typically like the ones that work.
Oftentimes the enclosure selection comes down to what size can I fit, and what are some of the aesthetics requirements of the venue, and how am I actually going to end up mounting them. Celtex has some great ones. Ventive has some great enclosures as well. Some manufacturers are now making a stadium-specific enclosure too for underseat. So pick your product and set your requirements, and then try to pick from there.
How much are those roughly a piece?
They vary. Obviously, it depends upon volume too, right, that you're purchasing. I would say, I hate to throw numbers around, but I would say maybe a good round number would be anywhere from $200 to $300 each, maybe.
All right, that's fair. Oh, somebody said that 250 pounds each at IP68 rated. Yeah, they seem to agree with you.
Yeah, and that's that's somewhat of a hard question to answer too, right, UC? Because I think if you've looked at NEMA enclosures, right, there's a wide, product gap, if you will, between kind of some of your, what I would call less quality manufacturers and the quality of those from like some of your higher end manufacturers that are putting equipment out there, right? Because you can get NEMA enclosures relatively cheap, right? But do you want it to be waterproof? What rating do you want it to stand up to? Things of that nature all come into play too on the price of it.
All right, that's cool. Thank you.
So I think we'll just kind of move on at the time, just to make sure we kind of get through some of everything at the time. But we'll talk about a little bit about spectrum design, right? So once we've designed our wireless network, if you will, from a physical perspective, right, then we also have to turn our attention to the RF perspective, right? How our channel is going to be laid out. Are we going to use something like radio resource management, RRM with Cisco, or an Aruba ARM or air match, a channel fly, something of that nature, right? And I think, at least in my perspective, and Chris, I'd love to get some thoughts from you on this as well, but from my perspective, I typically like to do a static channel plan at a stadium.
Absolutely. I know where the signal's going. I know what areas are important and which areas I can sort of deal with a little bit worse performance as far as channel selection goes. I'll set it. I set it static, and then we'll typically try to get early into the install, throw a bunch of APs into the coverage area and let them run on DFS channels. Get a better understanding of DFS events and possibly parse DFS channels out of the plan. So that way, when I'm doing the final channel plan, I'm not putting in DFS channels that I'm not going to be able to use.
Yeah, absolutely. And I think it's important to know too, right? If we use those static channels, right, then we've got a defined layout. We can make sure then that we don't have adjacent DFS channels, if you will, right, in adjacent cells. Because it's one of the things that you also have to think about, right, is what are your users going to be doing? What devices do they have? Are those devices DFS capable or are they not? Now, obviously, as time has moved on, right, in 2018, a lot of our devices by far would support DFS, I think, even from the mobile side of things, but there are some that don't.
So LPV in stadiums that we get the newest devices is that I think I looked up a little bit before the webinar. Consumer Electronics Association says that the average phone is 18 months old. So you've got relatively new devices that are hopefully supporting all the DFS channels, and in a large enough venue, you can't not use DFS. Period. There's just not enough. Yeah. There's not enough available for you not to. I think one of the Wi-Fi Trek webinars talked about, what was it, 2% of devices do not support DFS. Sure. Don't make things worse for 98% of people to service the 2%. That there's got to be a minimum standard. And if their device doesn't meet it, then they're not going to get coverage out in the bowl. They're not going to have service out in the bowl.
Yeah, I think generally from the U.S. perspective, right, most of the time I use all of our DFS channels that are available to us, with the exception of 120 to 128. Those sometimes you have to be careful with. That's where, weather radar sits and all. So you do have to be cognizant of, is that something that's going to be in close proximity to cause a DFS trip in your system or not? And then, generally speaking from a channels perspective, 144, it's one that was added when 11AC came out. Some devices support it now. Most that do AC will, but it's also something that you have to be aware of, right? Because there may be devices that are 5 gig capable that simply don't support channel 144 yet. And then you see kind of in the middle of the diagram there, we talk about house reserve channels, right? These are not specific channels that I would always house reserve by any means, but it is something that you have to be cognizant of, right? For, back of house functions, front of house functions, are there office areas, what I would call VIP users, that we always want to make sure that we have access for. So we kind of dedicate channels to those users by way of our access points and SSIDs that are broadcasting on those access points.
Or are they doing wireless video delivery in some of the channels that you're looking at, and it's not adhering to the Wi-Fi standard. It's just an analog video stream that is just taking up the spectrum. So you may not want to use that channel in your plan.
Yeah, talking about video broadcast, right? I know a number of years ago I was working with one of our professional teams during the playoffs, and about 30 minutes before the actual event started, the entire Uni 3 band in 5 gig went to 100% channel utilization and sat there for the duration of the entire game. And then at the moment the game ended, just a few minutes after ending, it suddenly dropped back off. Everything looked great. It was usable again. And I stood there scratching my head, for a number of innings, number of games, trying to figure out what in the world was going on, only to find out that the actual television broadcast crew there was utilizing that band for their wireless camera system. So.
Yeah, and then some of the particularly professional teams that you've got some allies in your fight against that, is that there can be frequency coordinators who are responsible for making sure that everyone's playing well together. So that way, not just that the public Wi-Fi is working, but that the video streams are working, and that the audio streams are working, and that the referee microphones are working correctly, and we're not stepping on each other. So it's important to talk to them as well.
Yeah, and kind of keeping along that same thread, you'll see on our next slide here. So this is a Ekahau depiction of a professional football stadium here in the United States. You can just see the massive numbers of access points, right, that are showing up on that scan. So you see, to kind of touch on your point earlier from, the number of beacons and all that you can see in the stadium, there's been some testing done. I believe it was in the Aruba documentation on stadium design, where a device was placed at one end, probably 130, 200 meters away from an access point that was broadcasting at its lowest power, and we were still able to see that signal coming from that access point.
Yeah, and it wasn't even an access point. I think it was probably even like a client to client, some kind of mobile hotspot to a client or something like that. Crazy, even not with the access point antennas, but with mobile device to mobile device or something crazy like that.
Exactly.
I don't recall.
Yeah, so then you think about the number of access points, right? The number of access points then that you put into a design for a 60, 70,000 foot stadium or seat stadium, could be, upwards of 600 to 700 or more, even in some cases, right? Depending upon the architecture of the venue.
Yeah, so that's crazy. And I'm telling you, when you hear something like 300 access points in a single location, and each is broadcasting, let's say 3-4 SSIDs, we had to do some work in our survey tool as well for it to be capable to handle all that data and take those measurements, every couple of 100 milliseconds. And just fun facts. We enjoyed developing our product further with the stadium guys. Thank you, Cisco Advanced Services, for example, by the way. They did a lot of patient work with us to get the product to stadium conditions. So I know Leslie McCarthy is listening. So Leslie, Josh, Matt, love you guys. Thank you so much for helping us out.
Yeah, and it brings up an interesting point as well, right? When we're talking about stadium design, right? A lot of people, are used to a typical deployment, right, where they're going to have 2, 3, sometimes even 4 or 5 SSIDs in there, right? And we're adding beacons every time we add an SSID out there. In a stadium environment, right, airtime is our most precious resource. We need to get people on and off as quickly as we can. So the last thing that we want is a large number of SSIDs broadcast, because the more beacons that are having to be broadcast, right, the less airtime we have for actual client data to transmit across the air. Right. At least
I guess the typical is 2, right? 2 SSIDs, something like that.
Yeah, 2 SSIDs is pretty common. I am not a fan personally of utilizing any type of .1x SSID. That obviously, when you're looking at the 4-way handshake process and the amount of time it takes for a full handshake and authentication to occur in .1x, right? That's, again, utilizing more resource from our airtime that we really don't want to necessarily have being used up, right?
Exactly.
And then, so you can actually, if you want to simulate this, Andrew Van Naj, he's got his beacon overhead spreadsheet as well as the iOS app. So take a look at how many beacons we can see on a single channel, or APs we can see on a single channel here, and run that through with 4 SSIDs. Even if you're running a 24 meg basic rate, it's not insignificant. And we're trying to sort of squeeze everything we can out of the airtime. It's not helping.
Yeah, and if you look at the screen, right, you'll notice that I changed the slide, and this is actually looking at 2.4 gig now. I think it's worth mentioning just briefly, albeit, that 2.4 is definitely something that you want to deploy in a stadium, right? Because again, airtime being our most precious resource, we want to be able to utilize as much of it as possible, even if we know that 2.4 gig is already going to be highly impaired. You know, even if we were able to squeeze out an extra 50K or 100K, you know, of usage, maybe for a handful of clients, something is always better than nothing in this case.
My opinion is that it's venue specific and size specific. Is that there's a point when, if you've got enough APs in the bowl, that 2.4 just isn't viable anymore. But it's 60 usable megahertz of capacity. So you don't just ignore it because you think 2.4 is dead. Do the math, do the calculations, and see whether it's worthwhile to use.
Absolutely. And you'll just kind of see this is a design built in Ekahau. I left the coverage in here just for the fun of it, but this is really just more, for my perspective, utilized for AP placement maps to hand off to my installers so that they have some general idea of where things are going. You'll kind of notice throughout, I've got some 2.4 gig radio shut off, right? Because, you know, while we want to use 2.4 in some cases, we don't all want every radio to be broadcasting 2.4, right? That would just simply be a little bit too much in a stadium environment.
And fun fact, you can, for example, model in Ekahau the people sitting on top of your APs. So you can, on the planner, you can drop the APs to like 20 centimeters height, and then you can draw an attenuating area of human fat that lies on top of those APs to attenuate it and all that. So that kind of stuff can be done in Ekahau, but not obviously the curvy slopes and stuff like that. I'm sure we're going to talk about like design and deployment and AP on a stick versus predictive on a stadium, stuff like that. Or are we? We have all of 3 minutes left. We're going to go over, but that's fine.
Yeah, we might come back to it if we have a little bit of time, right?
All right.
So just kind of moving on, we'll talk about supporting the wireless, right? So far we've dedicated everything to the design of our physical infrastructure. We've dedicated time to the design of our RF infrastructure, right? How we want to lay out the spectrum, you know, how we want to reserve some channels for house uses, things of that nature, right? But there's a number of things that we kind of need to keep in mind as we work in a stadium environment that might not immediately come to front of mind when doing a wireless deployment. So Chris, I'll kind of hand it off to you if you want to kind of talk through some of these things, and I'll just kind of adjust the slide as needed.
Sure. So it talked about the power, both from a mains power, a UPS power, and for the APs. LPV in stadiums are unique in that you're going to have a lot of the devices that are connected being a lot or almost all, if this is a Wi-Fi only network, relying on PoE. So if you're using AT and you're planning for 30 watts per port, a 48 port switch, just PoE. We're not counting any of the actual switch processing. You're 1,440 watts of power per switch. So you've got to plan for that on both the UPS side as well as the mains power side. Don't just assume that you've got enough power in an area. It's one of the few areas where you may actually be using PoE on every port, and trying to find UPSs that can service 5 or 6 switches in a closet.
And then you throw in digital signage, right? That's growing more and more popular, right? Lighting, things of that nature, right? It's definitely something that comes to mind.
Yeah. So just something to keep in mind if you guys decided to want to get into LPV. And then there's as far as the switching side, there's a couple of schools of thought when it comes to switching. Is do you do multiple 24-port switches so you're not sort of throwing all of your eggs in one basket and getting a little bit better redundancy, or are you just doing the 48-port switches? And if you lose a 48-port switch, you lose 48 access points, and that's really specific to the venue. What's their tolerance for failure? Is this public Wi-Fi only? Is POS running over this, where if you lose 48 APs in one area, are they no longer going to be able to take credit cards to serve beer, which will hurt the bottom line versus just a fan experience impact? So you'll have to have that conversation when you start to talk about the design. And then for some of the sort of tertiary services that you may need to add in to support the Wi-Fi. So you've got the switching, you've got the routing, DNS and DHCP. You cannot rely, and you do not want to rely on things like just Google DNS for all of the clients. That they'll not only will they rate limit you when they hit a certain limit, but you're adding additional latency to the customer. To the customer side, because you're waiting to go all the way out to Google to get a response for DNS. You need local DNS caching. You need DHCP services, preferably off of a dedicated servers, and it has to be sized for the venue. Don't just think that your switch can do it.
Yeah, I think that's definitely a good point to talk about when you talk about referencing sizing of DNS and DHCP servers, right? There's a minimum number in an LPV environment that you need to focus around of number of DNS or DHCP transactions per second, if you will, and definitely make sure that you're utilizing a professional grade product like a Blue Cat or an Infoblox or something of that nature, right, that can provide those at a rapid enough pace, right? Because typically, any DHCP or DNS server may be able to handle the load if you're looking at something averaged out over time, right? But when you're bringing in 20, 30, 40, 60,000 spectators all at once, right, you're going to have that sudden onslaught of hits, and you need something that can be able to keep up with those. Your typical Windows server, may or may not be capable of handling that type load or that type rush, if you will, on immediate entry of fans into the stadium prior to the event.
Yeah, and just because they have a VM environment that, Windows can certainly handle it if you size it and spec it accordingly as well. But just because the venue may have a VM environment and say, well, we'll spin up a couple of VMs for you, the hardware may not be able to support what you're trying to do. Mm-hmm. You need control. You need some level of control over this if you're going to be supporting the effort.
Yeah, and I see one of the topics right now in our chat window is talking about what size VLAN would you recommend for utilizing for usage in an LPV environment?
It depends. It really does depend. Is there a requirement for multicast, which I wouldn't, there we go, Sam, which I wouldn't necessarily recommend, but if there's no requirement for user to user across any of the SSIDs that you're doing, if there's no requirement for multicast, and at the AP, you don't let it get all the way down to your core before you block this. But at the AP, if you can block all that user to user, if you can block all of the broadcast services that you don't necessarily need, and really direct some of those DHCP requests as well, that you can deal with larger sized VLANs in /20/19s, and there's no real performance hit to it. You just gotta plan for it, and you have to understand what's actually going on before you size it.
Yeah, and vendor selection there, obviously each vendor has their unique mechanisms to handle with things like, broadcast to unicast conversion and things, broadcast multicast suppression. It depends on what type of traffic you're trying to honor in the stadium environment, things of that nature, as to how large a VLAN size goes. I've run as large as, /16s in some cases. And I know you're probably, a lot of the attendees are probably like, holy crap, that's a lot of people in a particular area, right? But, if it's properly managed and the vendor supports proper, suppression techniques and things of that nature, then it's something that can definitely be utilized. So, don't necessarily be afraid of large VLANs anymore, right? We have a lot more mitigation techniques and all like that we can utilize now than we did in previous years.
I think Aerohive has a pretty good white paper on broadcast with large networks over Wi-Fi and what you can do to block it.
Yeah, so we'll kind of jump to part two. You want to touch on routers, firewalls, and ISP stuff?
Absolutely. So for your routers and switching, just because it has gig ports or 10 gig ports doesn't mean that it's going to be able to do what you need to do at the scale. If you've got a friend at the manufacturer that you're dealing with, get a second opinion, look through everything, understand feature specific limitations. And this is, I guess, not just talking about the routers, but across anything in the venue. Understand the limitations of the hardware that you're using and the features that you're going to be using. Because if there are client count limitations, you're going to hit them.
Absolutely.
Firewalls, again, depending on the services that you're using. If you have no need for any sort of layer 7 analytics out of it, if you don't need to do any sort of inspection, if you don't need to do any inspection of HTTPS traffic, that your size of firewall is going to be different. That as you start to enable those services, particularly on the firewall side, that your throughput is going to be, your available throughput through that firewall is going to be halved easily or more. So again, understand the limitations of the features that you're enabling, understand the limitations of the firewalls that you're using, and work with the manufacturer if you can, that they know what their stuff can handle, and particularly if it's a visible environment, they'll want to help and they'll want to make sure that the right product is in there. But plan for the future too. Don't if you're a smaller venue and you're only gonna have 1 gig pipes, don't force a replacement of your firewall when you want to upgrade to 10 gig later on. Make sure that you plan for what you're going to need in a couple of years.
Yeah, and same goes, I think, for all of your infrastructure, right? Even your DNS, DHCP servers, things of that nature. I know I'd talked about sizing for a certain number, just a rough ballpark. So you roughly want to calculate DNS sizing based on 1 request per device per second in a venue like this. So if you've got 60,000 devices, right, you're going to need to plan on potentially up to 60,000 DNS queries per second. And then on your DHCP side, there's kind of a formula, right, that I typically use, but it's the number of seats multiplied by 5% and divided by 300 seconds to give you a rough number of DHCP discovers per second that you're going to look at. So for instance, let's take a 40,000 seat stadium just to kind of help make math a little easier. You're going to roughly anticipate about 6.7 or let's just say 7 to give a round number of discovers per second for your DHCP server, right? So definitely, some things that you need to think about, making sure that your servers and your backend infrastructure are sized adequately. And then off to internet uplink. Very, very important, I would say.
Yes, absolutely. That everything can be working great, but if you're oversaturating your internet connection, that no one's going to be having a great time. So make sure that you size it appropriately initially, and make sure you don't have to do hardware changes to upgrade it down the road. If you're getting a brand new connection, again, you're getting a 1 gig link, make sure that the point of presence that they're putting in supports 10 gig down the road. Try to make sure that anything that you've got it's a phone call to upgrade it rather than having to do hardware replacement. And then looking at when you're sizing it, and from a financial perspective, for large public venues that only have a small amount of full stadium events a year, if you're looking at 10 or 12, burstable connections are fantastic. Oftentimes they're built on the 95th percentile. If you're only hosting 2 full stadium events a month, you're not going to be charged for the burstable rate because you're only going to use it for 6 hours out of that month.
Mm-hmm.
So they can be a really viable option if you're not looking to have 10 gig all the time, or you don't need 10 gig all the time.
Yeah, and I think that's also something to keep in mind too, right? Is we're generally, when we're doing a stadium design and we're considering the wireless and all the back-end infrastructure, we're looking at it from a perspective of if the stadium was full, right? But typically our take rate is going to be much less than 100%, right? I mean, I think the stats out of one of the latest Super Bowls, or one of the last Super Bowls, was actually somewhere roughly closer to 50% than we've seen in the past. But still, we're not even talking about, more than 1 out of every 2 users actually connecting and associating to the wireless network at any given moment.
Yeah, and then redundancy. Again, this is sort of a financial and tolerance discussion with the venue. Is that a full-time 10 gig link is expensive, so they may want to have redundancy for POS and press and back of house services, but they may not want to pay to have have the second 10 gig link for public users. I would hope that they would do that, and would certainly recommend that they do that, but it's not always viable depending on what their financial situation is.
Sure, absolutely. Your larger stadiums, right, are going to look at that as saying, well, yeah, we're definitely going to provide that, right? They don't want the public shaming on Twitter to happen, right? That the wireless network went down at the most critical point in the game.
Yeah.
And lastly, 11AX. I know I've seen some questions and some comments come across Twitter about 11AX, how we think it's going to impact large public venues, stadiums, whatever large venue you may be looking at. I think the name goes a long way in telling you what its intended purpose is of high efficiency wireless. What are your thoughts, Chris, on how do you see 11AX helping us? Will it help, and when will it help?
So AX will definitely help. That there's a lot that comes along with it that'll help in very high density, particularly the OFDMA and resource units, being able to split that channel up into smaller sections and having multiple clients send at the same time. That if you wanted to look at, just because we'll talk about publicly available numbers, Extreme has a infographic on last year's Super Bowl, which has the peak throughput and then the peak number of clients that were connected. If you average that at peak, the average client there was only sending 300 kilobit per second if you average it across the whole thing. So there's a lot of clients that aren't sending a lot of data all at once. So if you can break up a lot of those small data transactions and send them all at the same time, we free up a lot of airtime, that they don't have to use the full 20 megahertz to send just a tiny little check-in or a quick WebSocket. That it's definitely going to be more efficient. We're not necessarily, I like the direction that it's going, over efficiency over speed. Is that AC brought a lot of good stuff with it, but 160 megahertz wide channels is not something that anyone is actually using. So I'm glad to see it going into high efficiency mode.
Yeah, I would agree. I think there's definitely some key points that you've mentioned around, resource unit utilization, being able to split the channel up, being able to aggregate, slots together, if you will, to have a number of users, transmitting it simultaneously rather than having to each take their turn waiting on the channel. Do you think that 11AX in itself will be a bigger help than maybe, say, adding 6 gigahertz to the frequency band?
That's a tough one, and I think the decider of that is going to be client adoption. Is when would clients be able to support 6 gigahertz, and when would the majority of clients be able to support 6 gigahertz? So we in the stadiums that we're gonna have AX clients quicker than most other venues. Is that the vast majority of the clients that connect are mobile phones, and like I said earlier, that the average one is 18 months old. So we're gonna get them and be able to use AX, I think, quicker than everything else, or than any other vertical. So I think AX is going to come first before the 6 gigahertz and the 6 gigahertz client support, and then we're actually going to be able to use it at some point. But as far as when a stadium should update, that's a really tough one, because there's a lot that goes into that. There's actual hardware support when it's coming out, which particular models of access points are going to support it immediately, and then code-based stability as well. So brand new product, brand new version of code. How stable is it going to be for the venue to be able to use it and have it work reliably?
And even like I think those issues will probably be resolved a lot before we have a reasonable number of AX clients, because you need to have that like 30 or 50% penetration of AX clients to really see benefits from it, right? So even that number of AX clients, when are we going to realistically see that? When the iPhone hits the shelves with AX. And the earliest point that will happen, that they will start shipping the iPhones with AX, earliest possible point is September next year, when the next iPhone will be launched. And maybe that doesn't support the AX, so it will be a year after. So it will be like 2020 when they will start really hitting the big number. So I mean, then it's already pretty close to AX Wave 2 plus 6 gigahertz. So it's like, to me, it's one of those don't hold your breath type of situation. So if you want, high efficiency, if your state, to me, I'm just saying, feel free to argue. I'm just arguing for the sake of argument. But if you want like high performance out of your stadium, upgrading to AX isn't going to do anything in the next 2 years. And that goes for any environment. I'm really sorry, sales guys, but it's just not a reasonable sales pitch to say AX will solve any of your problems next year.
Yeah, absolutely. I mean, if we look at, so we'll just kind of, let me pause this for a second. I'm going to share something else with everyone.
So yeah, while you're pulling up that, is that if you're doing a new install at this point and you've already got plans to do replacement, that I think for large venues, AX makes a lot of sense to be that hardware choice. Sorry, Sam, I know I'm going against what you had said, but there's just so much good about AX that can come. It's just going to take a while for it to actually get there. But there's not a reason for you to go out if you've got a properly functioning and it meets all of your requirements right now, AC stadium deployment. There's no reason to upgrade until the client support is there.
Yeah, absolutely. And then I think you look at the fact too, as well as, this is just a utilization calculator, if you will, that I put together based off of Chuck Lukashevsky's guide. So if we anticipate 41,000 associated devices in the environment at any given time, right, with the number of channels that we have available, which in this case, we're going to say we're going to use all three 2.4. We're going to hold back a few of the 5 gigahertz channels, so we're only going to use 21. Giving impairment factors and things of that nature, right? We're only looking at, down here, if you look at the screen, right, we're only looking at about 200K per user on 5 gigahertz, right? So we're talking about the amount of bandwidth, right, that is used on a per user basis in an environment like this is very, very small. We mentioned the fact that, you're roughly looking at about 300, kilobytes per second, right? For, the average, I think, transaction size these days in wireless is roughly 256 kilobytes or something like that. So we're talking about small bursts of app updates, things of that nature, right? We're not talking about long sustained updates that we're looking at needing to provide high bandwidth for. So, those are things that you have to keep in mind, right? Is, do we really need faster Wi-Fi, or would we be better off just utilizing 11AX as high efficiency mode, right? The things that it brings for high efficiency. And I think that right there kind of sums it up into saying that I would definitely take personally the higher efficiency over simply having faster throughput like we've had out of amendments in the past.
Yeah, and to me, like, little do I know about stadiums, but my experience is that, instead of waiting for AX, maybe it's time to, rebuild your stadium or refactor some of your stadium's RF design based on, for example, many of the, tips here. And that will give you a huge performance boost while we're waiting for AX. Like, all I'm saying is, most of the stadiums, or many of the stadiums, have not just outdated APs, but also an outdated RF design. That was maybe best practice 8 years ago, but certainly not today.
Well, and you see that out of even newer stadiums, though, right? I mean, there's some, there's some stadiums out there in arenas and venues that I've been in that were deployed, 1, 2, 3 years ago, even that, due to, whatever the circumstance may be, just poor quality by the installation company or things of that nature, right? Where antennas may not have been aimed properly, the system may not have been designed with the use cases in mind necessarily, just things of that nature, right? That always, within the stadium environment would warrant some type of, I would say almost biannual or annual, if not, sooner health check of the environment, right? Because those things are always changing.
Yeah, like a site survey for every stadium every 2 weeks, using a sidekick and a fresh new copy of ESS. I'm all for it, man.
And I think it holds true not just in stadiums, but in other verticals as well. A well-designed previous generation deployment is going to beat the crap out of a poorly deployed and designed current gen.
Yeah, I would say for 11AX, mileage may vary if you're deploying a new stadium now and you're going to try to go ahead and go to AX, not knowing if we're going to have the final ratification of, what inclusions may be in that amendment, as well as we have to think about it this way too, right? These are first gen access points, right? So we may not necessarily be able to rely upon the hardware as much as we would say something like an 11AC Wave 2 access point. So I know that it's kind of going backwards a little bit, but do you want it to work and work well now? Or do you want to have the potential of having some, tough explanations to give to those power that be later on?
Yeah, it's absolutely, it's all a balancing act. Is that your reliability versus performance, and recognizing that the large dollar amount that goes into a stadium deployment and not wanting that to perform poorly because of a first gen product, or manufacturers that don't even have an AX product yet in their books.
All right, Jerry, you see that's all we've got planned right now. If we want to move into some questions.
Right on. Yeah, we're only 20 minutes over our time. We hopefully you guys are all right with sticking around. Obviously, this has been a good discussion, good topic, a lot of questions and dialogue going on in chat. So I appreciate everybody hanging out on the attendee side. We still have a few hundred people on, so you guys cool with pounding through a few of these questions we got on the board?
Absolutely.
Yep.
So the first question here that is an interesting one is, what is the sweet spot for the number of clients supported per AP?
So obviously, right, there's marketing hype of how many connections per radio that an access point can handle versus kind of the reality, right, of what we would intentionally design for. And for myself personally, that's going to largely vary upon the coverage model that I'm going to use. So if I'm going to design an overhead coverage model, I'm typically looking at somewhere around a maximum of 150 users per radio, right? I'm not saying that we're going to put 150 on 2.4. I like to keep them on 5 gig, but strictly from a 5 gig radio perspective, I'm going to look at about 150 users. And then
so Scott, is that seats or clients connected?
So that's going to be clients connected at max, and then I'm going to allow the overage in the association ID table on that access point, which for most vendors is around 256 or so. I'm going to allow that gap, if you will, to handle those transient users that are just simply moving through the environment. They're walking down a concourse, they want to stay connected, so we don't have to bring them back on through the process, the 802.11 auth and association process. We want to keep them connected, even though they're not really doing anything. So we still need to consider, though, that access point needs to have association slots for those users to stay connected. When I'm looking at an underseat design, however, I'm going to look at, say, maybe 100 users per access point radio, or a 75 even. I think it largely depends upon, again, coverage pattern, architecture of the stadium, and things of that nature. But my general rule of thumb is about 150 concurrent users, devices, on an access point for overhead, and around 75 on an underseat.
And when we're talking about association limits, is particularly for entrance and exit, don't set those APs too low that they're gonna get slammed both during the initial walk-in and then even more so after the event is over. That you'll see 600, 800 connections and on those APs that you're not expecting them to be able to do anything. It's just that they've roamed over there and are that's the last sort of sacrificial AP on the way out.
Mm-hmm.
It's going down with the ship.
Well, we talked about reserving house channels, right, for uses. I think that's a good example right there of a use case for a reserved channel for our ticketing scanners, right? So as people are coming in, the same process is going to happen. Those, first access points that users see and devices associate to are just going to be absolutely slammed during the entire build up to the time of the event start, right? So we want to make sure that we have enough access points, enough RF spectrum available from radios in that area for users to connect to, but we also need to make sure that we have that dedicated spectrum available for those ticket scanners, am I right? Because, it doesn't do you a lot of good to have this great stadium Wi-Fi if you can't get users in the door.
Yeah, dedicating channels, radios, or even full APs to just ticketing in those areas where there's so many people coming in all at once is a great idea.
All right, next question we've got here that's the most upvoted question is around the design standpoint. How are omnidirectional antennas deployed versus directional? Where and how?
That's a really good question. So oftentimes a lot of in suite areas in particular that the omnis are used more heavily than some of the concourse or bowl areas, but it's not necessarily about ignoring omnis. It's about picking the antenna design that fits what you're trying to do with it. So if you've got something like a higher gain omni, that there are scenarios where you can use it in an underseat because it's pushing the signal more towards the customers the clients that you're trying to reach. And then the omnidirectionals, particularly in the suite areas or some of the back of house, that's the right antenna for that design and that deployment. Scott, I'm sure you have some opinions on it too.
Yeah, so talking about antenna patterns, right, and omnis versus directionals, things of that nature. So if we look at an overhead model, right, generally speaking, you're always going to use some type of directional in order to be able to guide that signal where you want it. And depending upon mounting height, it's going to vary with what antenna gain I'm going to utilize, right? Because obviously, as we get a higher gain out of the antenna, right, we start stretching that balloon out, right? More like a balloon animal, right? It's going to be pretty long, pretty thin. It's going to be more directed versus a low gain omnidirectional antenna, right? Where we're going to talk about, we're going to take that balloon and we're going to push it in at the points, right? And flatten that out. We don't really want the signal, right, going amongst all the other access points in the ceiling space where they're mounted, right? We want something that's high enough gain to get that signal down to where our users are.
The other piece I would add to that too, that I often forget and have to be kind of cognizant of, is it's bi-directional, right? So it's not just the transmit that we often visualize in heat maps and stuff, but it's the receive as well. It's the ears. So do
Absolutely.
We want that antenna listening in all directions, or do we want it focused and only listening in a certain direction? So yeah, keep in mind the clients, and not just the clients, but other APs in the environment. So what direction do we want that antenna listening?
Yeah, those passive antennas, right, that we have, because obviously we're not adding or decrease, any electrical gain for the signal, right? But they're definitely something that you need to think about from a reciprocity standpoint, right? The more clearly that we can broadcast to someone, the better that we're going to hear from them as well. And in a stadium environment, right, with a lot of low power devices, that's definitely something that needs to be at top of mind when designing.
Yeah, and you get that signal rejection by making sure that you're not listening over in areas that you don't want to be listening from. But you also have to remember that the client isn't directional, so its return signal is not going to follow that same direction.
Yeah, You know, and then we kind of flip that to the flip side, right? If we look at under seat deployments, right? Our users are closer to the access point. They're spread out more horizontally. So we don't necessarily want that, you know, one ray beam shooting straight to a particular client, right? We want that flatter omnidirectional pancake signal, right? That's a low gain so that we can reach more users with a higher average, you know, SNR across the board, which then increases MCS rates, leads to a better overall experience for our users because we're utilizing less airtime, right? The quicker they can talk, the quicker they get off the air.
Good stuff. All right, a couple more questions here. When will the predictive element of ESS be able to understand tiered seating? What do you think about that one, UC? You want me to throw you that curveball? I can take
so when will ESS support curved seating? Was that the question?
Yeah, the tiered seating, the stadium seating. We do have a feature that can help with some of that, right?
Yeah, like holding the floor and multi-floor and all that stuff. But that leads to a bigger question of like predictive versus AP on a stick on a stadium and the effort included. I mean, theoretically, you could build a hugely complex model of the stadium and plan it that way to a reasonable accuracy, and then to a lesser accuracy you can do it today with ESS by you know, cutting some corners. But what do you guys think in terms of like, well, Chris, Scott, you have all the tools in the world available for you for Wi-Fi design. How do you guys go about designing Wi-Fi? AP on a stadium, AP on a stick, more predictive, heavy, a combination of both. How does it work for you guys? First, Scott, and then Chris.
Go ahead, Scott.
You can go ahead first. I'll piggyback off of you.
All right. So I don't design carpeted enterprise without going on site. There's a lot that you need to get on site, particularly for some of the distances, and getting a good understanding of what the venue looks like. So I definitely for the designs, there is definitely an on-site component to it. It's sort of a combination of the AP on a stick, from my perspective, a combination of AP on a stick and predictive. So oftentimes we're doing an AP on a stick to figure out what the actual real world signal is, and then sort of cheating the predictive to match what the real world is. That overcomes some of the limitations with as far as being able to model angled seating, because we're already compensating with that, or compensating for that with our sort of cheating of the predictive.
Yeah, no, I definitely agree with that. There are few venues that I go into that I don't do some sort of measurement with an AP on a stick or AP in a box under the seat, however you want to look at it within a deployment strategy, right? To kind of measure what the real world attenuation of that signal is going to be, to know what my actual true expected coverage is going to be out of an access point placement, because no two environments are the same, right? We're going to have you have this NFL stadium that has these nice luxury seats in one section, a lot of padding, a lot of added attenuation, if you will, may or may not have some type of metal in the seating. Traditionally older seats use metal bottoms and metal frames and stuff of that nature. I know a lot of stadiums these days, only the supports themselves are metal and the rest of the seat itself is a polymer, if you will. So, and obviously anytime you change materials or anything about that variable changes, right, it's going to depend and change the signal propagation. So I would agree with Chris. I do a lot of active measurement in the stadium, utilizing, AP on a stick with Ekahau or, an air check tool or something of that nature to kind of help give me a real world expectation and then map accordingly with some other type of planning software, if you will, for creating those installation maps and such.
Very good. How about maybe two more questions? I see we're already about 30 minutes over here. So this is, I think, a really important one. I don't know if we really discussed this much around the client side of things. When you're designing, what are you designing for as your maybe worst or least capable client? What do you keep in mind there? Or what do you use for that?
It's always an iPhone because that's the majority of the clients that end up in the venues. So typically it's a 1 to 2 channel iPhone that we're designing against. And then depending on the other areas like ticketing, for instance, that they just have terrible devices. So you're trying to grab an actual device and test with that.
I had a fun experience with the ticketing one recently. They were using some old ticketing scanners that were 802.11b devices. 2.4. We couldn't even enable the 11. Raise the minimum require rate up to 11 because they couldn't handle that. So we had to have some of the lower data rates even enabled on top of supporting 2.4 for those critical devices. Right, from a monetary standpoint, this is a ticketing piece of the thing. So it's not, we can't just say, oh, we're not going to support those devices and you can't scan tickets.
But there's got to be some give and take on it. Is that you can't be expected to support a business critical application on a device that doesn't meet some reasonable degree of standards. So I mean, B was a long time ago, and it's time for some of the ticketing institutions to start to upgrade some of their devices.
Yeah, I agree. That's certainly part of the remediation plan, but it can be a big ship to try and turn. So it's usually not going to happen overnight, especially if you've got hundreds of these types of things, and it's a proprietary system or something like that. It obviously can take some time. So you have to maybe have a remediation plan, a temporary remediation plan at least to get you there. All right, one more question here. Appreciate everybody sticking around for as long as you have. And the last question here was one from John here around, is there concern with shooting signal 2 to 3 feet away from viewers' heads? I have seen this in some of the other arenas, large 4-foot panels besides the seats. I know we touched on that a little bit as far as distance, with underseat deployments. Any considerations that you have to take there, especially if you're using these kind of high gain directional antennas in these environments, and how close a proximity those are to the attendees?
So the maximum permissible exposure is the guide for the distance unless you're putting it right against the back of the seat, that it's a transient user walking in front of it. They're not sitting there constantly, and in addition, they're sitting there for 3 hours. So it'd be different if it was there underneath someone's desk where they sat 12 hours a day or 8 hours a day for a couple of years. That the MPE is that safe exposure limit. So that's what we designed for. That's what we built for. But there's also this different MPE distances for cellular versus Wi-Fi. So they were talking about a 4-foot panel. I don't know of a Wi-Fi manufacturer that has a 4-foot panel. So I suspect that was probably a cellular antenna. But for our designs, the MPE is what we build towards.
Nice. All right, guys. Any closing thoughts that we want to leave the audience with?
I think I'll just chime in and say, I hope that we've mentioned something maybe that's helped you in your efforts to look at stadium design and things of that nature. I will admit I am by no means the world's foremost authority on stadium design. Been privileged to work in some of the facilities that I have, and also been a privilege to be part of the webinar and share some of those trials and tribulations with the audience today.
Yeah, absolutely. There's always more to learn on it, and the design methodologies and processes are constantly changing because we learn new things about what works and what doesn't. So if we were to give this webinar next year, we'll probably cover different topics. But yeah, it's been great to be on here. And then if there's any follow-up questions, both Scott and I are pretty active on Twitter. and I hear UC is sometimes on there too.
Yeah, wireless certifications are just a license to keep learning, right? Not a definitive you know it all.
I would like to take a minute to thank these guys for, it's not just taking 2 hours now of your time, but preparing for the webinar, actually volunteering, coming to us and volunteering to do this for free. We do not pay. Sorry guys, if you only realize this now, but we do not pay for these webinars, and you guys just do this, because you're good persons and you want to help the community. So please, everybody, join me for thanking these two gentlemen for doing this and sharing their expertise without getting any monetary benefit or anything else out of it. Maybe an maybe a used Ekohau hoodie once worn by Mikko or myself.
Is it autographed?
It's autographed.
Did I hear it was used? Do you wash it first?
Do I ever wash my clothes anyway? No, I burned them, man. After I use them, I burned them. That's how I roll. Anyway, it's getting late here in London, as you can tell. Thank you, Scott, for that picture, especially. Also, I'd like to thank Jerry and Joel and Nick Turner, you guys who actually make these webinars happen, as well as Hannele for the graphics, except for this one. This one.
There's always the Nicolas Cage tribute, you see.
I do appreciate that. Actually, come to think of it, I do have one more thing. Jerry, any closing words?
No, I've got nothing. This is great. I learned a lot throughout the presentation, and echo what UC said. I really appreciate you guys coming on and sharing all your experience and insights onto this topic.
Thank you so much. With that, let's continue the discussion on Twitter. Scott, Chris, Jerry, myself, Joel, Nick, everybody can be found there. So happy Halloween, mofos, and thank you, attendees, for watching. You're the reason we keep doing this stuff. Awesome. Happy Halloween, gentlemen and ladies.